Hey, hello there, and welcome back to another Advent of Code video. So today we are continuing on with Advent of Code, and we are almost there. It's gonna be day 24, and well, I'm expecting this to be probably quite challenging. So I don't know if I will be finishing this on this sitting because I want to end recording at 6:30 or something. So let's give it a try. Let's see what part one of this is about and give it a go and see what happens. So this is day 24, Blizzard Basin, again with the alliterations. And I'm already seeing like a grid-based problem, it seems. Well, with everything replanted for next year and with elephants and monkeys to tend the grove, you and the elves leave for the extraction point. Partway up the mountain that shields the grove is a flat open area that serves as the extraction point. It's a bit of a climb, but nothing the expedition can handle. At least that would normally be true. Now that the mountain is covered in snow, things have become more difficult than the elves are used to. The expedition reaches a valley that must be traversed to reach the extraction site. You find the strong turbulent winds are pushing small blizzards of snow and sharp ice around the valley. Oh, cool. It's a mountain winter setup. Well, I guess it makes sense. It's Christmas over here in December when this was. Now we are in the middle of the year, and actually here in the southern hemisphere it's the middle of winter too, but it's doing like 28-30 degrees Celsius, so we're having a mini summer, and yay global warming. Anyway, let's get the phone out of here with my cats. Where were we? So, yeah, the blizzards of snow and sharp ice around the valley. It's a good thing everyone packed warm clothes. Yeah. To make it across safely, you will need to find a way to avoid them. Fortunately, it's easy to see all of this from the entrance to the valley. So you make a map of the valley and the blizzards. Your puzzle input, for example, this thing. The walls of the valley are drawn as hashtags. What was the name of this thing? Like pounds or whatever. Everything else is ground. Clear ground where there is currently no blizzard is drawn as a dot. Otherwise, blizzards are drawn with an arrow indicating their direction of motion. Up, down, left, or right. Okay, so here there are two blizzards, it seems. And I guess these two are the entrance and exit points. The above map includes two blizzards, one moving right and one moving down. In 1 minute, each blizzard moves one position in the direction it is pointing. Okay, so here this has moved over here and this has moved to besides the wall. Due to conservation of blizzard energy, as the blizzard reaches the wall of the valley, a new blizzard from the opposite side of the valley moving in the same... a new blizzard forms on the opposite side of the valley moving in the same direction. Okay, so this thing has wrapped around on this side. Very nice, very realistic physics simulation there. After another minute, the bottom downward moving blizzard has been replaced with a new downward moving blizzard at the top of the valley instead. Okay, and the other one has moved to the right. Because blizzards are made of tiny snowflakes, they pass through each other. After another minute, both blizzards temporarily occupy the same position, marked 2. Okay, so they can overlap. After another minute, the situation resolves itself, giving each blizzard back its personal space. Great. Finally, a after yet another minute, the rightward facing blizzard on the right is replaced with a new one on the left facing the same direction. Okay, makes sense. This process repeats at least as long as you are observing it, but probably forever. Okay, here's a more complex example. Right, so it's kind of similar in size, but it's like full of blizzards. Your expedition begins in the only non-wall position on the top row and needs to reach to the only non-wall position on the bottom row. Okay. So you start here and you end up here. On each minute, you can move up, down, left, or right, or you can wait in place. You and the blizzards act simultaneously. You cannot share a position with a blizzard. Okay, so you have to like go around the blizzards or move with them. In the above example, the fastest way to reach your goal requires 18 steps. Drawing the position of the expedition as E. One way to achieve this is, okay, so we start here, we move down because these two are going to move to the right. Oh, and at some point there's 3 blizzards on the same place. So here, oh, really interesting. You need 2, move down. You need 3, wait. You need 4 more, move up. So okay, you went down here, waited, then went up again to the same position. You need 5, move right, move down, move left. So yeah, it's a very windy path or meandering path because the blizzards move you around. Then you move up again, move right, so you're like doing circles. Then you wait, move down. Okay. Yeah, finally you reach the end goal. What is the fastest number of minutes required to avoid the blizzards and reach the goal? Okay. And then the puzzle input, I guess it's going to be a bigger map. Yeah. And it also seems like the start is all the way to the left and the end is all the way to the right, although the instructions said that it was the only non-wall position here, so maybe we can do the parsing like correctly and not assume it's going to be all the way to the left. But yeah, this thing is like full of blizzards. There's even like few spaces not covered by blizzards. All right. So this seems to be like a pathfinding problem, but a tricky one, I guess. So one of the things that immediately comes to mind is that these blizzards, they are going to move like in a periodic way. So like, I don't know, it's difficult to see here, but let's increase the font size. So here, for instance, considering the first row, or any row, like all the blizzards that are moving to the right, for example, on that row, are going to be are going to move to the right at the same speed. And this size, like I don't know, however many characters are here, let's say 80, you know, after 80 minutes, they're going to all have looped and be on the same starting position. And that's going to be true for all rows and all blizzards moving to the right or to the left. Like they are going to loop every, I don't know how many columns there are, minutes, they are going to be on the same position. So I think that's going to be interesting, maybe to avoid like recomputing the map for each for each possible move. You could have like the map already like pre-computed for like the amount of columns and the amount of rows like multiplied together or something like that, and have that as the map, and then like do yeah, think of that Yeah, because for each given minute, like the state of the map is going to be like predetermined, because the pattern is eternal. So yeah, that seems doable, I think. And I wonder if, well, let's jump into the code first. Advance. What I was wondering is whether we can use the Dijkstra algorithm that we have already used for a couple of these problems. So yeah, in day 12 and 16 we're using Dijkstra's algorithm to find the shortest path. I wonder if that will work for day 20, for this day too. Oh, and by the way, the previous day, day 23, I ended up doing some interesting optimization here where, well, this is kind of irrelevant to this video, I guess, but previously this thing was taking like a whole second to run, and if we do cargo run release now, well, it's going to take a bit longer because I'm recording, but yeah, now it's taking around 200 milliseconds instead of a full second, and when I'm not recording, it's like 150. And what I did to improve the runtime is that instead of storing the elf's position on a hash set, I'm putting them on a vector, and I'm also recording their positions on a 2D grid, like a map of booleans, like if it's occupied by an elf or not. And these guys were like spreading around the map, so to avoid having to expand the map and consider negative positions and things like that, what I do is when parsing the map, I'm pre-padding it to like 5 times its size, so leaving very wide margins on every direction, so elves can spread around and never reach the size of the map. And this seems to work correctly, and it's a pretty simple thing. It was a pretty simple thing to do. I don't need to like regrow the map or anything, and it wasn't so much more code to add. Like in fact, when I'm like processing the proposed moves for each elf, it's like just assigning this map with the previous elf position, like turning it into false because it's no longer there, and moving the elf to that new XY coordinate. So it was a pretty simple change, but it was a nice runtime improvement because of, when you have a 2D grid, you can do direct access to that memory instead of doing hashes for each position. Anyway, that was a very random comment. Let's go to day 24, which is called something Blizzard something. Blizzard Basin. Blizzard's Basin. Okay. Let's also add this here. And let's add a file called the same way. We can have our usual rank function. Input is going to be this, and it's going to return a string, and an empty format string. Okay. So where do we start? I guess we can start by parsing this. And I wonder how should we parse this? So one thing that we could do, since blizzards can occupy the same position, So like the map is going to be like a 2D vector of something, but of what? We could have like an enum blizzard with different directions, like up, down, left, and right. But the problem of doing so is that each square on the map, each tile, can have neither of this or any of this. And I'm not sure if you can, like in Rust, define enums as like flags, so you can have like each of these be a different bit. I guess I could also write them in binary, but that way you can have like or them together, and you can have like a single tile, but you also would need like the empty tile, which would be 0. But I don't know, I think constants are like more useful to do this. I'm not sure if enums work for this. Let's maybe Google that. Rust, this would be enum bits flags, or as bit flags, how do you implement? Well, it seems like it. Oh, I always forgot that on enums you can do this wrapper and tell the compiler what size to use for the enum. Public flags. What is this thing? Okay. Yeah, it makes more sense to have like constants. It's interesting that here it's defining the constants without the type. Interesting. Oh, it says struct. Oh, I didn't know this thing. That's U8. Huh. The more you know. Oh, it's using this bit flags create here. So this is a macro call, and this is absolute magic. Okay, I don't want to use macros for this. Oh, I guess that is an external package create, right? Yeah, it seems to be. Yeah. Won't be using that. Just plain old constants for me. So that's one alternative, I guess. Okay, let's do the parsing of the map first. So I guess we don't need to parse the walls. Yeah. Although maybe having the walls might be useful for like in the 2D vector itself, so that you can, you're never going to go into one of those, like to avoid negative indexes or something like that, because these walls are all at 0 and like x0, and these are at y0, and having them there is like, okay, if you're standing here, you could make the calculation if it's going out of bounds, but also you can ask what is here, and okay, there's a wall. Or if you're standing here, it's like you are going to have 2 walls as neighbors, and that's gonna be fine. So maybe having the walls is useful. Like it seems useful, but I'm not sure, because I was also thinking about this wrapping around thing. By the way, we can measure. Oh, I didn't create the input file. Let's create one of those. Day24 txt. Let's copy these inputs. How big is this? It's going from, it says 10 columns selected, so I guess that's 100 characters wide. And from 2 to 36, that is 35 rows tall. Okay. Yeah, so I'm not sure if having the walls is going like on the 2D map makes sense, because when parsing, that seems to be like making the parsing like more generic. Like it could be parsing walls on the middle of the map and whatever, and you would be doing that sort of computations, but or finding the path avoiding those walls, but it's not necessary really. We can make assumptions and assume like this is just a rectangle and avoid thinking about walls altogether. So I think I would prefer to do that. So yeah, the blizzard this way, I think it won't make sense. I think having this as constants is gonna be better. So const, let's do uppercase. Let's use, why not use bytes for this? Okay. And then let's say, well, let's have a function to parse map. I'm also wondering if it makes sense to like our goal. Let's also see something like when we are here on the first turn, this blizzard is going to move right, but also this blizzard is going to move right and appear here. So the first turn we are going to need to wait. So we cannot not even assume that we are starting at, if this is 0, 0, we cannot even assume that. So either we are starting at 0, -1, which is not very nice, or this is 0, 0, or I guess maybe even 1, 0, because it's 1 on X and 0 on Y, and everything else on this map is like shifted by 1. I don't like, don't like either of those. Yeah, but maybe using signed integers for position makes more sense, and then just using, converting them to unsigned integers when accessing the map. I think it improves things when wrapping around and that sort of things. So what is this going to do? It's going to take the inputs and return a map, which is going to be say a vector of bytes, and we are just going to OR these things out. All right. So how are we going to do this? I guess we can first, we're gonna have to drop the first and the last line. So in order to do that, using the lines iterator is maybe a bit clumsy. So let's do let lines equal input lines and collect. So first we are going to collect our lines. This is going to be collected into a vector, and then and I wonder also if this should return like a tuple of like map and starting and ending positions. Maybe that makes sense. Yeah, let's do that. Like start and end. Type point is going to be just a tuple of 2 signed integers. Yes. So let's say first let's pass the start and end x. Let start x is gonna be first line. We can do something clever here. I think we can do let's first line, then lines. I don't know the syntax for this. Then last line be this. Can you do that? I have to slice you. Can you do that? So only can be a oh, these things are experimental. Really? Wasn't there some sort of syntax for this? I thought there was. No, exclusive range path. I thought there was something like this. So how do we separate Rust? Extract middle of slice pattern. That's a terrible search. I seem to remember that you could do something like that, like patterns for slices. Rust slice pattern matching. Daily Rust. I think this one is. Woohoo! Tuple slice. You can do this. Actually, a slice it's the word irrefutable. Yeah. Okay. I thought this was possible, but I might be wrong. Huh. Okay. Really, it's like this will be the middle lines, and it would be nice to have that. But okay. Let's not think about that. Let's say that start x is this, and we can have the characters, and we can have the position of the well, isn't there like a position of or something like that? Well, we need a predicate, but the predicate is pretty simple, right? We want to know the position of the first empty thingy. And this is gonna be 0. For this it's gonna be 1 actually. But I think that's okay. That is okay, I think. This is probably an option. So let's say first row must have empty tile. I'm gonna do a bit of cleverness here and say something like, okay, let's have start and end x, and it's just going to be lines 0, line set, lines length -1, and map those two with a function that does exactly this. So line, and you don't like this because you cannot map tuples, but you can probably map arrays, right? Yes, I think you can. So let's do it with an array. Same thing. Great. Look at that cleverness. I'm a bit unfocused already, so let's actually debug these two. Start x and end x. Let's say to do for the rest. And here it's just called parse map. Sure. And cargo run 24 warnings. Okay, 1 and 100. That seems okay to me. These two guys are going to be U size, but I will want them as I32 actually. So in the end, we're going to return a top tuple with the map, and the start is going to be start at x, well, start x, and y is going to be 0, and the end goal is going to be end x and lines length, I think, as I think. All right. Then we need to parse the map. So let's say let's map. It's gonna be probably type inference will help us here. It's gonna be a lines, but let's take the middle ones. So starting from 1 up to lines length -1, non-inclusive. Then this we are gonna what? Just, well, iterate over this. I guess this is a slice, so you can probably iterate it. Map into something and then collect into a vector, right? And then each of these lines, we're gonna do something. Gonna have the line no, actually line. Again, no, we're going to get the characters and map to something and collect again. And here I guess it's going to be the meaty part of this. We're gonna match that character, and if it is an empty tile, I'm gonna say empty. Then if it is say, well, let's go in the same order that we defined our constants. So if it's this, it's gonna be up. I guess this means not just up, but like Blizzard up, Blizzard and Blizzard down, or whatever. We can maybe rename those if it's if it is confusing. Down. This is gonna be darn it. Left, and finally, if I can type something correctly, let's go slower. Right. Okay, and to be exhaustive, we need to say, hey, unreachable, expected character. Okay. So this doesn't seem to complain. Let's run this. Panicked. Oh, the walls, yes. So here I guess each line we could also do a similar thing that we did for this. That would work, but I think we can also do something like, hey, trim matches, and the pattern like trim the walls, and then do this. But if we do that, well, if we do that, the map, I think that's going to be fine. We're going to be trimming this, so the first element in the map is going to be this. So yeah, I think that seems fine. Yeah, it runs without errors, so that is good. Let's do like a little assertion. Let's assert EQ that map, and I'm not extracting this. So we're gonna have a map start and end. Let's assert that map 0, 0 is what's right. Okay, and let's also that I guess 1, 0 is up, or I guess 0, 1 because this is Y first and X second. Huh. No, we asserted both right, but this was right and up. Not even gonna read the message. Yeah, okay, so the assertions passed. This seems to be parsed correctly. So okay, parsing done. Now the juicy part, I guess. How are we going to do this? Let's try to remember how to use this Dijkstra thingy. So, can I check your usages? Yes. So, what was this thing about? Oh, this is one that I stolen from. I stole from somewhere. I don't remember. Probosidae volcanium. Oh, the valves thing. Yeah, you have to open valves on something. Beautiful. Yeah, but you have like a graph of connected things. Okay. Like here, the closure that we are passing to this shortest path distance is very simple. That's nice. I wonder if the other use of this, which I think it was a more of a grid thing. Yeah, height map. Oh, look at that. this looks very similar to what we are doing now. Actually, it looks very, very similar. We're expecting things. Yeah. Here we didn't do the clever thing of using a tuple for that. All right. But yeah, here we are defining neighbors closure. We're gonna do something similar, I think, for the for this problem of the blizzards, but we will need to know, yeah, like the state, that you pass to the Dijkstra thing. So Dijkstra thing is going to expect. Oh, it's actually expecting end just as being like one of these things, right? So the start. Oh no, you just passed the start. And where does it get the end? Calculates the shortest path distance start. Oh, it returns a hash map of everything? What? Here we're starting from the end. Yes. So this gives us all the distances. I don't know if that's what I want. Do we have two of this? No. So yeah, now I seem to remember something, that we were needing all the distances for some reason, and I don't know that reason. Instead of like passing the end goal here. So we are accumulating all of that in hash map. Great. That won't help for this, I think, because yeah, that won't help here, because the map is not static. It's not like you have a given distance from any point of the map to the end. It also depends on what minutes you are starting on. Yeah, so that's cool. Maybe one thing that we can do is to show the history of this. Yeah, here I copied the Dijkstra module also from the previous year. That's awesome. Yeah, and I guess here we made the Dijkstra thingy a bit more generic. Instead of returning all the distances, it's just returning the shortest one. Yeah, and here we're passing the ends. So you know what? I may want to copy this and revive it. Shortest path distances. Let's also have a shortest path simply. And I changed quite a bit of things. So distance instead of costs, that I think can be fixed. So everything else seems to be. So I even wonder if this is going to work, but I think this is closer to what I want. So let's revive this. We can probably also implement this in terms of the other one, but let's not think about that. Let's just try to redo this thing. So this is going to be distance. It will look the same as before. Here we are extracting distance. Okay. Like this. And here what we call path dist instead of path cost. So let's do the same. So the main difference is that that here we are exhausting, like calculating. This is assuming that all the starting positions are like knowable, and they are finite, and then we compute all the distances from there. Yeah, so from this start to any position of the map, and then we would get the last position that we want, and we just extract from there. But instead, we want to check if the value that we are checking is the end. And if it is, and instead of mean cost, let's rename all the costs here. So this is mean dist. And are there any more costs? Successor. Why are we doing this here? What is the type of this? Successors. Oh, this is the function. So I think that we were assuming that the cost for each successor was not constant. So I think we can also assume this here. And just add 1 here. And what else is different over here? Distance and get blah. This is the same. Why are you complaining? Because this distance. Oh, probably the signature of this thing. So the function that we are passing as successors. Yeah, this into iterator should be. Just give me the next one. So everything is going to be at distance 1, I think, because here distance means minutes basically in this problem that we are implementing now. So okay, let's assume that this is sort of a minimum path and that we didn't screw it up. All right, you know what, I'm tempted to maybe try it with very stupid input. Not even this one. Oh, this is now very big. Not even this one, but we can increase one. but this one that is very sparse, and we can just try to go with the empty tiles, right? And see if the distance makes any sense. And then we can think of avoiding blizzards, actually. Okay, so, oh, by the way, yeah, the thing is, this end here is just a node. I think it won't be, we cannot make it just a node. It's going to be like a closure of when to stop. And this is because the state is going to include the position that we are in and the minute that we are in. So let's have end be, so this t is basically the state of things. This f of t is for the successors. Let's make this guy can we make this like an fn of t or reference to t or whatever into bool? Is this enough? Create objects must include dynamic. I think, yeah, because this is going to be like another parametric thing. Great. So this is going to be the predicate, I guess. P. So P. I think this should, okay, work. At least for the type signature. It's a bit noisy, but okay, I guess. I do wonder if this is sort of the IT parameter is needed. Like, can't we say something like this sort of thing and just not have this? No, right? The into iter. Okay, I'm not understanding that. It's not the time to learn all these Rust type parameters, like complex type parameter magic. So instead of asking if the value is equal to that end value that we want, we're going to call this thing end predicate. And just call it with the value. So if it is the end, then we return the distance, right? I think that makes sense. We increase distance by 1. Yeah, that sort of makes sense. Okay, let's copy this, put it in the input. What's gonna be the minimum distance here? Avoiding the blizzards, but not considering the moving. So it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think. 10 turns, 10 minutes, whatever. So let's do how was the name? Shortest path. Shortest path. Starting from start as a reference. the end, we are going to say, here we are going to be, like each node is going to be, let's say, a tuple of a position and a minutes. And we're going to ask if this position is equal to the end. And is this going to be a reference? So let's dereference it like that, I think. And the successors function is going to be the interesting one. So here again, we're going to take a position, and I guess we can even destructure this here. Position is going to be xy, and the minutes that we're in. Something like that. So let's minutes be these. We're gonna expect this, or let's unwrap. We can think of, let's expect there must be a shortest be a path from start to end. Okay. And let's print this. Okay, so here it's assuming some things. Yeah, but everything should be inferred from this neighbors function. So let's always here on the neighbors, let's just simply do something that sort of type checks, and then we can just do x plus 1 and y plus 1, and that will be the next position, and have minutes plus 1, whatever. So now the position, what are you doing? Why are you assuming that this is that? If the type, oh no, the start should be not just the start position, but also the starting minutes, which is going to be 0. That makes more sense. Okay. And these, what is not an iterator? This thing. Oh, what happened with okay, this is the predicate, and this is the successor function. We can, I guess, put it into an array that can be into iteratable. Okay, we are starting from the start. That makes some sense. But now let's actually implement the logic here. So that this now type checks. That is fine. We want to keep something like that, but we want to make it more interesting. So let's have all the directions, filter the ones that are out of bounds, or I just thought something that is annoying, but okay. When we start, we can only move down. That is interesting. And the condition for that is not so obvious, I think. Unless we model the walls. Yeah. Okay, so one thing that we can do, I guess, is here we could return a dynamic vector or something. So let's say if xy is simply the same as start, we're gonna special case this, and then we can think somewhat better. So if it is the start, we can only move down, I think. Right? Or I guess actually we don't need to special case that, right? Because we are using signed integers for this. I guess here we can dereference, because minute is also going to be a reference. Yeah, dereference everything, so we have nicer values. So we can have all of the neighbors, filter the ones that are out of bounds, and filter the ones that are blizzards, and that's it, right? So we can have x plus 1 y, then this is moving right. Let's also consider moving down first, y plus 1. Then we can consider, we will also consider weighting. That's interesting. So that would be xy staying on the same place. Yeah, let's consider weighting after that. So I'm sort of prioritizing, since we know that we have to move down and to the right, I'm considering those moves first. Then weighting, and then let's consider moving up, which is going to be this and y minus 1, and moving left, so x minus 1 and y. We're gonna have these guys and map them. We can also call this thing xy, although maybe it's not. No, we don't want to map. We want to filter. We have to iterate over this to filter. Okay. So filter. We're gonna filter the ones that are out of bounds. So how do we do that? Well, if x, I guess, greater than 0, yeah, it has to be greater than 0. And you know, what I probably want is like access the map, and that's it. Like, yeah, this is more like a filter map, I think. So we're gonna do let the tile be hey map, you're a rock star, did you get playing? Oh yeah, something like that. Give me the y as usize, so this is gonna be wrapping around, and then give me, and then actually row give me the x as usize. So if this is out of bounds, we just get out of this, and I think we can just use this magic syntax. In fact, we can probably even use it here, if I'm not mistaken. Hey, this is optional, then get this. Right, and if we have some tile, well, we can say, hey, sum x, y, I think. Yes, all of this is unused. I know. This is actually going to be your neighbors function return. So let neighbors. Okay, and here we actually want to say if tile is empty, then return sum, we can move over there, else none. And this you don't like because this is, okay, we can dereference. All right. I think this sort of makes sense. I hope that I didn't do something very stupid. So these are going to be all the neighbors. Can we just return the neighbors here? Neighbors, because neighbors is into iteratable. Woohoo! That return. What is the type of neighbors? It's optional. Why is it option? Like, why is this? Wait. Filter map. It should actually. Can we collect this into like? Can this be? Oh, I think I know what the problem is. So here we want to, yeah, something like this, right? Because we need to actually have the minutes too. So that's, I think, the problem. Neighbors is going to be this. We are going to be filter mapping this, and then we are going to map each of these positions into a tuple of position and a minute plus 1, because that's going to be the next state. This position, yeah, I guess it is correct to be that. What's the problem? Oh yeah, we are taking minutes. Just you say move closure, and then this thing again cannot return temporary value. What is the temporary value here? That is the temporary value. Yes, because we are not using. Oh, we can use into iter here. Is this valid? We don't need to dereference here. Look at that. Does this run, or or does it keep looping forever? It looks like it's the latter. Okay, we are not. This is kind of a problem, I think, with this Dijkstra thing. Because since we are always returning minutes plus 1, we are never in the same state. So temporarily I will not add 1 here to this minutes. Yeah. Let's do this and see if it runs. Must be a path from start to end, and it didn't find one, so that's pretty interesting. Okay, let's do something like print here. And let's say neighbors of well, xy are gonna be what? Well, debug print of neighbors. Let's clone this iterator so we don't screw up the original one, and then collect into a vector of something. Do you like that? Now it's the turbo fish. Now you like this? Okay, let's see. Woohoo! Okay, neighbors of 1, 0. So this is, I know. I have to subtract 1 when accessing the map, I'm pretty sure. So neighbors of 1, 0, so this is the start, x1, y0. In the map itself, it should be, I think we should subtract 1. Which kind of makes me think if the map should include the walls or not, but I'm pretty sure it's about this. We are only using this to access the map, like subtracting 1 to access the map, but then we are considering xy relative to this like the start and end, if that makes any sense. No, that doesn't make any sense, I think. No, wait. It shouldn't, the start shouldn't be, it shouldn't be that, I think. I think we should fix start and end. Start x yeah, I think we should subtract 1 from this. No, not subtract x, subtract 1. And here the starting y position is going to be -1, and this end position I think is correct. Lines length or not, because lines, like for instance in this one, is going to be 7, but the thing is 5 rows, so I think actually it's like this -2 if I'm not mistaken. Lines length I'm not too sure about this. Let's print also here. Now let's debug start and end and start is x equals 0 minus y minus 1, that makes sense. End is x4 1 2 0 1 2 3 4, yeah, and 5. Oh, but we are never going to consider that because it's going to be out of bounds. Yeah. That's interesting. So I think to avoid this check of out of bounds, here we can say, hey, if this xy is equal to the end well, consider this a valid neighbor, so we can actually consider it. What's your problem here? Oh no, it's not return true, it's just return, we are filtering here, so yeah. Okay, and you don't like this, you probably can make a copy of this. What's your problem here? Syntax. This is an if condition. And now we have probably capture outer variable. Oh, we are capturing the map because of this stupid move. Can we not do that? Yeah, we can avoid doing that, but that's good to do. Oh, look at that. We have the shortest path. Shortest path is 10, without any blizzards moving or anything, but it is what we wanted to be. So, okay, that should have been pretty easy, but it was more complicated than I thought it would be. But we got it in the end. So, quite messy, I think. We are like special casing this end condition here and whatnot. But it is sort of working. I think it won't work if we do +1 here though. And we can, oh, it actually did work. That is interesting. We can avoid this thing. Okay, so we are doing the +1 minutes. Cool. Yeah. Okay, and now I think we should start doing the computation of the blizzards at any given minute. So instead of saying, hey, tile is empty when accessing the map like this, I think we should say, hey, give me the map at this given minute, or I guess minute +1, and then get it, the tile there and ask if it is empty on that given minute, if it makes any sense. I think that should work, but I have to get going actually. So I'm excited actually to try that when I'm back. But if I don't follow in the later at night, I will probably continue tomorrow. So I think that's it for today. If you have been, thanks for watching and see you next time. Bye bye. And we're back. Okay. So it's a bit later at night, and it's after some dinner and climbing, but I wanted to jump back into this, and I have had an idea of what to do. I've been thinking about this while going to the climbing gym, but where were we actually? I think we had something running, yeah, for this simple example. Let's do, well, run. Yeah, we were finding the shortest path, avoiding these blizzards, if I'm not mistaken, but we are not making any simulation of the blizzards. So one thing that we can do is, yeah, I want to check where were we actually. Yeah, so sorry, I got a bit confused there. About the simulation of the blizzard. So the thing that I was thinking before in like the previous video, I don't know if I would split it on video. So the previous sitting was that, yeah, these blizzards are cyclic or cyclic. Sorry for the pronunciation, in their nature. So they go, for instance, this right facing blizzard. So blizzards that move to the left or to the right have cycles of the size of each row, of the width of the map. And the blizzards that are moving up and down, they have cycles of the height of the map. So in this case, I think it is 5 in each direction. But on the actual map, this thing, I think we saw that this was 100 in this direction. Yeah, 100 columns selected, and 35 in the vertical direction. So that means that every 100 turns, all the left-facing and right-facing blizzards are going to be in the same position as the start position. And every 35 turns, all the up and down blizzards are going to be in the same position as the starting position. Those numbers are not the same, but they will match eventually. And also those numbers are not co-prime, so that means they have some shared divisors. So they won't repeat, like the first time that the cycles repeat, both of the cycles together, it's not 100 times 35, but it's a smaller number. So 35 is 5 times 7, and 100 is also divisible by 5. So instead of being 35 times 100, which is 3500, it should be that divided by 5, if I'm not mistaken. So 3500 divided by 5 is 700, which I think should be the least common not divisible, this least common multiple of those two numbers. If I'm not mistaken, we can try that out, doing hundreds else this common multiple with 35. Oh, those colors are very bad in contrast, but yes, this is 700, although I'm sure that's not going to be readable on the video. So yeah, after 700 turns or minutes, the map is going to look exactly the same as the initial map, which means, like this was what I was thinking before. We could generate those 700 maps, like assuming this is going to take more than 700 turns or something, but we could generate those, and then when it's the 701 turn, we can just access, wrap around and access the first map, because they are going to repeat. So we don't need to do the actual simulation for each minute or something like that. We can just have static data. But I think even better than that, we can do even better. We can have only I think that we can have the starting condition, the starting map, and a given minute, and we can just know if there's going to be a storm, a blizzard in that position, in that minute, I think. So let's go to the simpler example, this one. So yeah, for example, considering this right-facing blizzard, if we want to know for this position, for instance, the second position after the blizzard, hey, is there going to be a blizzard here at minute 2? Well, yes, we can say intuitively yes, but why? Because if we look to the left of this position, two places, 1, 2, there is a right moving blizzard. So at minute 2, there's going to be a blizzard here. And at minute 3, there's not going to be a blizzard here, because if we go one more to the left, this will wrap around and be here. There's not a blizzard here. So at minute 3, at least we know that there is not a right-facing blizzard, and we can, I guess, do the check wrapping around in every direction. That should also work for down-moving and up-moving blizzards too. So, for example, consider if this were a left-moving blizzard, and it's going to wrap around, and we are standing here. The same logic applies. If we know, like, we want to know for this position if there's going to be a blizzard 2 turns at minute 2. Well, we can look to the right, one place and then another place, so wrap around. And yeah, there's a left-facing blizzard here. So at the start, so there's going to be a blizzard at this position in minute 2. So I think with that logic, we can just, with the initial map and a given position, a given xy, these xy's that we want to check, we should be able to know if there's going to be a blizzard here, there, and if we can move to that position or not. So yeah, we also have this check for the end, which is not very nice. We want to check here we are doing these minutes. Actually, I want to rename this variable minutes. Instead of minutes, let's call it just t for time or turn or whatever, and we can also do the same rename here, even though we are not using that variable. So we are also checking if the x, y variables are in bounds by doing this conditional get on the map. So I guess I would prefer to first filter out the x, y coordinates that are not in bounds, and then we have, like, to not confuse this logic with the logic of looking to the left or to the right and wrapping around, because that's going to require wrapping around logic, but this is just bounds checking. But also here, we are doing this if this thing is equal to the end check, which is because the end tile is like outside of the 2D map that we don't want to filter it out, right? But I think we can probably remove this check if we have reached already this position, like the tile above the end. We know that, you know, the end is just accessible in the next turn, right? So we can, instead of trying to go to this goal, we can try to go to this goal and just add 1 to the computation, I think, because we can always move, unless we can have a blizzard here. I don't know if actually we can have a blizzard there. Let's actually check that in the in this column. There doesn't seem to be any. Let's look for that. Oh, if I select that, it's already been marked. But if we, no, there's no up moving blizzard. And actually, there's no up moving blizzard in the first, neither on the first nor the last column. That's interesting. And down moving blizzards, yeah, no, there aren't there either. So I don't think that's a coincidence. I think that's probably done on purpose to avoid the starting position and the ending position from having blizzards, also because you have no wall to make the blizzards bounce around. So that's nice. That's kind of clever. So we don't have to worry about that. And then yes, when we reach this position, the one above the end, we know that we'll reach the end on the next turn. So we can have that as the goal, I think. So this is start, end. We can yeah, we can just have the end be, instead of this thing that we did of end x and lines -2, we can do -3, and it's a very questionable number there, but we know what that means. And here we can say, well, total minutes, and just add 1 there. And I think that's gonna be the same, well, not for the actual map. It seems that the actual map doesn't have any, well, no, we cannot do anything because we cannot even start here. We cannot reach the end. There's no connecting dots. Actually, the dots are very sparse here. It's going to be very difficult to start moving around. But that's also kind of nice for Dijkstra algorithm, I think, because it also restricts the movement quite a bit. It's kind of like moving inside a maze. But if we go to the simple example, we should, I think, still have 10. Yeah, we still have 10 as the result, so that makes sense. So yeah, and now we shouldn't need this because the end should be contained in the map itself. Yes, if we run again, we get 10. That's good. All right. So now let's do something else. I want to have this x and y converted to like bounce checked. So we're gonna filter this first. We're gonna have x and y, and let's say that, well, x is greater than 0. Yeah, does this make sense to do also? I think it does. First doing the bounce check, so we don't even consider neighbors that are not in bounds. Yeah, I think that would simplify the logic of when accessing the map. And x less than, well, what is the width of the map? I guess it's gonna be map 0 length, and y is greater than 0, and y is less than map length. You don't like that because I don't know Rust syntax yet, it seems. We can dereference here. Why does filter takes a reference but filter map? I guess because it's mapping and it's consuming then. Okay. And we cannot, well, this is, this I guess has to be as I32, and this also. And I guess once we made this filter, we can actually know that x and y are are positive and inbound, so I guess we can already convert those to U size. But I mean, afterwards we are using signed integers, so we would need to transform them back into signed integers, so it doesn't make much sense, I think. Okay, so now we know that those are in bounds, so I think here we can avoid doing this and just do map y as U size and x as U size. Don't need to dereference this. This should still work the same. All right. But now we don't need to worry about bounds checking here. And what we can do, let's maybe extract, why do we have this filter map? Well, because we were, this should have just been a filter, I think. I don't know why we were mapping, to be honest. No, I don't remember. I don't know why we were doing filter map instead of filter. Let's do filter and just like ask if tile is empty, and this should still work the same as before. All right. And now instead of asking if the map is empty at the beginning, let's ask if the map is empty at t+1. That's what we want. So let's maybe extract the function. Let's say is empty, because I could have a function that says, hey, map, give me what is on this tile in x, y at time t+1. But there could be multiple blizzards there, and I don't care about multiple blizzards. I care if there is at least one, or conversely, if it is empty or not. So let's say position is empty at something like that. Yeah, whatever. We're gonna pass the map as a reference, I guess, and x and y positions. I guess we can even say, hey, this is a position, and pass that guy, and t+1. And we're probably going to have this, right? Does that make sense? I think it should. I think it should. Yeah, I also wonder if here it would make more sense to actually pass the x and y already converted to U size. So that guy doesn't have to worry about out of bounds checking or anything like that. It knows that it's already in bounds. So let's pass x as U size and y as U size, actually. Tile is empty at, okay, let's generate this guy. Well, the generation was sort of alright. Do we have a map type? I think we did, right? Yes, we did. X and Y is U size, and T is I32. Why I32? I have no idea. It could be U size, to be honest, but whatever. All right. So what do we do here? Is empty at? Well, let's go like think in each direction. Directions, well, we can start with the up direction. Actually, I think now that we are thinking in these terms, these don't make sense as constants anymore. I think we could just have them as an enum. Yeah. But wait, well, if they are constants, it's fine too, I guess. For the purpose of this, we can then change them to enum, because in the starting position on the map, there are no overlapping blizzards because they couldn't be drawn. They can be overlapping at some future time, but in the starting position they are not. That's also a nice simplification, and also kind of a nice hint, I guess, that you can simplify things looking at the starting position, because the instructions are kind of deceptive or deceiving, I guess, in some way, because they explain a lot how the blizzards move around. So you get the idea in your head that, okay, you have to simulate the movement of the blizzards, but I think you don't have to simulate anything. You can just know where they are going to be. So let's see. For any given position, let's consider the up position. So to know if there is an up moving blizzard at xy, we have to go down at time t. We have to go down t times and wrap around the height of the map. Yeah, and ask if there is an up moving blizzard there at the beginning. So let's do that. Let's actually extract width and height. So width is going to be map 0 length, and let's height be map length. And then, okay, what did I say? So if we do x plus, oh, you know what? T is going to be nice if it's a U size, because that way we can just do arithmetic with that. So if x plus t, all of that mod, we know that these things are positive, so yeah, mod height, if we access the map with that and there is an up moving blizzard, so if this is up, then this is not empty, right? So if this condition is true, then return false. I think it's that simple. Here we are accessing with x. No, so the I say x, this should be y. Y plus t, we're moving down to find the blizzard that's going up there. And so this is in the y position, and let's do it in the x coordinate too. So I think that's one check. Let's do the same, but for the down direction then. So this would be, well, I guess y minus t, but in order to do that, we have to wrap around. Yeah. We have to wrap around. Now I'm thinking that using signed signed math here would be better, because if we did that, we get a negative number, and then we can just do how was this called? Euclid mod, yeah, rem Euclid with height. But this is gonna underflow if we are using unsigned. So let's actually use signed numbers here. So we are going to, yeah, we use the signed things, but then we have to be converting. Well, I guess that is fine. And let's use this rem Euclid why does it have a rem here? Is it not the same? Oh, it's just a modular operator. So rem Euclid with height again. So it looks just the same. Again, we have to say SU size. Oh, and we also have to convert this. Well, let's convert it here because otherwise, yeah, I don't really like doing this this amount of type integer conversions. I sometimes wonder if I'm doing things wrong, to be honest. Well, here we're going up t times. We're doing the same here, and we want to ask if there is a blizzard moving down. And in that case, we say, hey, it's not empty. In the end, we're going to just say true. But we want to do then the same check for left and right. So for left moving blizzards, we have to move right. So we're gonna do this same thing, but for X. Here we're just gonna access Y. We're gonna do X plus T moving right, and take the remainder with width. Then we're gonna do something very similar, but going in the other direction, in the left direction, to see if we have a right moving blizzard. And that's going to be it, I think. I think that's all the logic. And otherwise we return true, it is empty. We can have some comments for this magical logic, but I think I just want to try it out. What's the problem here? To force the closure to take ownership of T, blah blah blah. Yeah. Just copy that T. Do a move. Come on. What's the problem? You're probably taking ownership of that, right? What's your problem? Yeah. Okay, don't be a move closure. Let's see. Yeah, but come on, like T is... It's a copyable thing. Why do you care about this? T plus 1. Can we call that like let T2 be T plus 1? And here just use T2. I think it's going to be the same problem. Yeah, it's T2, okay. Because this is a local variable. we should say, so then for this closure to be moved just as in this one, because we need to add, but then it's going to be, I think, taking ownership of the map, which it shouldn't. I know a trick to fix this, but I would rather not have to do this kind of thing. But well, these debug lines, let's say this is a trick. Let map be a reference to map. We shadow the name of map to be just a reference, and here we don't need to take a reference again, and it all works now. It's magic, yay. Okay, so it still takes 10 turns, but we don't know if this is actually good. We can try with the, I don't know if I want to try with the actual input. I want to try with a more complex example. Actually, we can write a test for this, and we can copy the 23 test, which was also a map kind of thing. So we can have this. We paste, and we didn't, and I don't know why we were trimming here. I don't even remember that. But okay, for this example, we what was the number? I think 18. So for this sample, the answer should be 18, and I don't think we need to trim, because the lines iterator already trims the first and last lines, I think, right? Well, let's leave the trim just in case, and let's run. Run 24. Well, that's not what I wanted to do. Let's run the tests. Cargo tests. We actually got 18. Wow, I was not expecting that. And with 19, I am so surprised when tests just pass first time, because these are quite tricky puzzles already. And man, okay, that's great. Should we try the actual input then? You know, I don't have really high hopes of the Dijkstra algorithm that I coded working for this. But there's only one way of knowing that. And let's do a run in release mode. Well, let's run it in debug mode first, just to catch overflows. And yeah, there was a panic. There must be a path. So we didn't find a path. That's a bummer. There should be. But it did find the path for this sample, which did involve some waiting. I'm pretty sure. Yeah, there's some turns that it waits. But we don't have a simple way of knowing which path it was, I think, because we are in this Dijkstra algorithm, we are only keeping the distances, but not the direction that we were coming from. So I don't know if we can reconstruct the path that was taken. And I hope that part 2 is not about that. Well, it could be. We would have to modify the pathfinding algorithm, but in this mess, maybe there's a problem at the beginning, because at the beginning you have to wait, I think, because yeah, look at that. You have to wait. So maybe we are not even having, so let's think about that first case. Where are we? Here. So when we are filtering, like the neighbors of the first position, one of those neighbors is going to be down, which is y plus 1, this one. And this is the only one that will be in bounds, so it will pass this filter. But then it won't pass this filter because the tile won't be empty at turn 0 plus 1, like turn 1 or the second turn, because this blizzard is going to wrap around and be here, which is a bummer because we have to start waiting. And this xy is out of bounds, so it's going to be filtered by this, which is not cool. It's not cool. Darn it. I'm going to add just a special case here. So let's call this thing inbounds. Yeah, that sucks because these are neighbors. We also want to consider waiting on this position. So if it is the start, like it's a very special case because we model the start as outside of things. So we're gonna say something like, maybe the waiting, no, yeah, the waiting makes sense to have this, but maybe it doesn't make sense to do the bounce check. But wait, if the first, if this is out of bounds, can we still check this? I don't think we can. No, I don't want to call these things with an out of bounds. So we're gonna say, okay, you're either in bounds or you are the start. So xy equals start. Beautiful. And again, we are gonna filter if the tile is empty or if it is the start. So this is start or this. This is kind of a clutch, but I think it should fix that problem for. So let's run the test again. Test still pass with that condition. Let's now run with the actual input, and we got an answer. My cats are playing over there. What are they doing? Okay, so my cat decided to open a door and took some things out. We got an answer actually, and it didn't explode, and it didn't take that much time to be on debug. And actually, I wasn't expecting this to get an answer. I was thinking that this Dijkstra algorithm would maybe hang like looping around this map, because there might be cycles that you can like take without reaching the end. But I guess that's that was not a problem. Like I was thinking that maybe I had to do some modular arithmetic on this time to make it loop around every 700 minutes. So like do something like this final map, have it like be mod 700, but or maybe implement some more advanced pathfinding algorithm like A star, or my cat is looping around the house now. No, but anyway, let's try this answer actually. I don't know why I'm talking so much. Is this answer correct? Is 230 minutes even reasonable? Yeah, it seems enough to move across the 130 like width and 35 height. So let's try it. And yes, it was actually the correct answer. That's awesome. At least for part one, I thought that this was going to be much harder, but I think it was very good that I took a time to think about this and came up with this idea of like not even simulating the whole storms or blizzards, I should say. Let's see what part two is about then. So as the expedition reaches the far side of the valley, one of the elves looks especially dismayed. He forgot his snacks at the entrance of the valley. Oh no. Since you are so good at dodging blizzards, the elves humbly request that you get back for his snacks from the same initial conditions. From the same initial condition. How quickly can you make it from the start to the goal, then back to the start, then back to the goal? Oh, interesting. In the above example, the first trip to the goal takes 18 minutes. The trip back to the start takes 33 minutes, and the trip back to the goal again takes 13 minutes, for a total of 54 minutes. All right. This is interesting for part two. Cat is playing around. So, okay, this is the answer to part one. We took this time, but now some of the clutches that we made for part one, sort of like this thing of asking if it is the start or the end. It's like, okay, maybe they don't work. But yeah, we know that the start can be not inbounds. I'm wondering if we can implement part two quite easily, but let's first add these changes just in case, because we have a working part one. I think I'm going to extract this shortest path function and sort of parameterize the start and end and the starting time, that here we're starting always at 0. And this add of 1 we are not going to include that in the extraction, I think. Yes, I think. Extract this into a function. Is this extraction sensical? It kind of is, actually. Although I would pass the map as the first parameter. And of course it doesn't recognize the names of things, but that's all right. These two are points. Map is gonna be here. Have to pat. Actually, I can remove the reference to the map now. Can pass this. Well, it's not points, it's just a point. And we also want to parameterize this 0. So this is going to be start time. Which we said was, I think, an I32 after all. And we're going to start at 0. And not just a fun name. Let's call it, well, shortest path is not a bad name for this. Yeah, let's say, hey, use this Dijkstra thing and call this this with the name Dijkstra here, and we're just going to rename this to shortest path 2. All right, name spacing is a good idea. If we run now, I think we should still have the same answer. Yes, indeed. And so for the test, actually, we want to have 54 minutes for this sample. And what do we need to do for part 2 then? So let's call this minutes actually first trip time and then yeah, we have that. So the start and end here, I think we are going to like shuffle them around a little bit. Say note, start can be out of bounds, but end needs to be in bounds. Let's remember that, because that's the assumption that we are doing. Either you are in bounds or you are the starts. But the end must be in bounds. Yes, yes, yes. Otherwise we would be filtering out. Although we could maybe ask, okay, are you the start or the end? And that would also, I guess, work. Maybe that would work, and we wouldn't need to do this +1. Yeah, maybe let's do that, and then we can consider something. But I would like to have start and end be more symmetrical. So then the end here is not going to be this weird thing of -3. It's actually this thing now. And so now we're gonna say, okay, you're either in bounds or you are the start or you are the end. Very kind of repetitive and probably not very efficient, but what you gonna do? We can think about this later. Now this note is not necessary anymore, and we don't need the last one there, and we can cargo test. This will fail now because it's expecting 1854, but we are still printing 18, so that is all right. And if we run day 24, we get, it took longer than before, but I wonder if that is just noise. Yeah, it might be noise. Yeah, but it is the same number as before, so that is fine. And we don't need to do that +1 thing or anything. All right, so this is the first trip time. Let's say, back trip time is gonna be the shortest, same thing, but going from the end to the start and starting at first trip time. And then let's say that is the distance of this back trip time, but it's not like we are starting here, but this initial time t, we are using that to access the map at the future time, but we are not like this is going to give me the amount of minutes that this back trip took, but not the, we have to add that for the third trip back. So what is going to be a good name for this? Start. So let's say back to start time and then back to end time. It's gonna be this thing, first trip time plus back to start time. Oh, and I guess, yeah, integer conversions. So I'm wondering if I could have just a mutable variable for this, but yeah, whatever. As I32 again. Kind of ugly. Let's actually do, okay, first trip time. Let's mute total. Yeah, total time is gonna be this first trip time. And then we're just gonna do, hey, total time plus equals, go from the end to the start, starting at total time as I32, and then do the same going from the start to the end, starting at again total time, and just add this thing to the total time. Okay, and then print the total time. Does this run for the test? And yes, the test now passes. It is 64. And what if we run in debug mode? Does this work? And yes, it took 1 second, but we got an answer. 751, and now I'm sort of confident about this. Let's see. And it is correct. That is very nice, actually. I wasn't expecting the part 2 to actually be simple, and even part 1 wasn't that difficult. And look at this. This looks amazing now, the map. The forest with all the green, and the volcano with all of this lava. Oh man, this looks amazing, and I really want to try day 25 now. But yeah, this was great. And it wasn't that difficult either. So let's add all of these changes and maybe clean up the code a little bit before committing and calling it a day. So we can get rid of that old printing. This neighbors thing is like, okay, that is exactly what this function should be called. So we can inline this variable. We don't need it. We can maybe even extract this thing, call it neighbors. Let's see, let's write it into variables. Successors is the name, but why doesn't it? I think neighbors is a name. Where does the H go? Neighbors. It's a difficult word to spell, but what is the problem with this? Implementation of FN1s is not general enough. What? One type is more general than the other. That's an interesting. Expected this trait, beautiful. A function that takes a tuple of a tuple, sure, but found this, okay. The closure does not fulfill the lifetime requirements, so now considering introducing closure parameters. And what does this parameter mean? Do you have a suggestion? Like, I don't know what this syntax means there. What does it mean to say, hey, you are of type ampersand? That's not valid syntax, right? Yeah, it's not. Okay, so yeah, have some like a type parameter. So you know what? Let's not inline this. Let's have it like this. No problem. And I was wondering if maybe instead of taking this as a tuple with the position there, we could, well, it's actually not that bad. It's not that bad. I was thinking of maybe having a 3-element tuple, x, y, and t. And here we could just map to x, y, and t plus 1. And yeah, I think that could work also. I don't know if it's better actually. But let's try it and see. Instead of position here, we have an xy and xy t plus 1. And what else? Here, I guess we'll need xy and ask is if this xy is equal to the end position. Does this work? Okay, and the start, I guess we would also need to destructure this, which is like, this works, but I don't think it's better than what we had before, so let's go back. Not so much back. There must be, yeah, okay. Let's also add maybe a node here. Node starts and end maybe off bounds by 1. Yeah. So the main code of doing this parsing, doing this first trip time, great, and then accumulating, I think it's quite alright. Yeah. Start time. I mean, the start time could be unsigned, I think. It doesn't make sense probably for it to be signed. And then we are passing it here. Just because we are doing arithmetic with that over here. Because the xy. Yeah. Yeah, let's do it like that. I would like to think if there's a better way, like of avoiding this. Hey, is this inbounds or start and end, or the start or the end, because those are valid positions. Because this is a filter with an or. And this is just to cover the case where, well, we want to consider the end that is out of bounds, and we want to consider the start that is out of bounds too. So I guess it is fine. It's not pretty, but it is fine, I think. And then we have this condition of tile is empty at. Let's take a look at this. Width and height. Great. We'll do this modular arithmetic. We can add a comment here. So the tile at xy is not empty if there is an up moving lizard t rows below, yeah, 10 rows below, wrapping around. Right, tile at xy is not, see if there is an t rows below. We can maybe say it like this. And the same for and then check. Well, we can put this comment over here and do a similar check for all other directions. And by the way, these directions we can probably make them an enum. I think that they want to be an enum. Because yeah, we made them bit fields, but they don't need that because we are not even doing like or left or something like that, like bitwise operations. So yeah, let's change them. Let's do an enum, not direction, tile. So a tile could be either of these. Yeah, we don't need any of those, just these guys. And we actually want to, well, use, how do you, is there transform to uppercase, lowercase, title case? Yeah, awesome. That's very cool. I think we can leave the name spacing for these tiles, so gonna do the same basically as before, but just with these enums. Title case. And yeah, we're collecting, but this, then the map is going to be vector of tile. Look at that. That's really good. And now here we can do the same. Tile, title case, and I think that's it. Oh, we cannot compare, of course. We can though do, we can just say, hey, is this tile left, right? If we do this, I think it should work. Okay, so we will do that. Let's do it with multiple cursors. We're gonna grab this guy, delete the equals sign, go to the start and say, hey, if let equal this, yeah, look at that, then false. You can probably combine all of these conditions. I guess we can also ask if these things match. I think actually that might be, instead of doing this, maybe this even cleaner to do matches macro. If this thing matches this, oh no, the formatting definitely doesn't make it cleaner. So let's go back to this. Okay, so if there is an app thing going in this direction, yeah, I think this is fine. This should still run. And yes, it does. It took 2 seconds this time. Did I? Oh no, this is just noise. Let's run it in release mode though. Release. Well, 200 milliseconds. This seems fine to me. And yeah, and in total we took, well, 700 minutes. 700. I do wonder if it would make some sense to do the modular arithmetic trick that I was thinking about. So here we are wrapping around t plus 1. If we just do this, does it change anything? Well, we know it's 700. Let's hard code this and try it for this. No, the runtime doesn't seem to change. The answer doesn't change either, but this makes no difference. All right. So far the code review, I think all of above this is fine. And then the parsing code. I think there's probably some things to clean up here. Oh, I think I actually looked, I googled how to do the pattern matching that I wanted to do before. So we can, instead of doing this access to like lines, then line length -1, and then this other extraction here, I think we can do something like similar to this. Well, no, actually, say let's, well, not shouting. Let's start, then if you do this and end and assign lines to this, I think you can do this. No, you have to slice this guy, take a reference and say, hey, well, if let blah 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 blah. I think that this is now a valid condition, yes. And to grab this middle thing, you just have to say, hey, middle, give the name and say at this thing. And then in here you have access to start, middle, and end. Or you can say let else panic. Expected to have more than 2 lines. Input should have more than 2 lines, yeah. And then instead of doing lines 0, you can say start and here these are the middle, and this should still work as far as I know. Yes, it does, and it's slightly cleaner, I guess, not so much to be honest. Yeah, to make it a bit like a start what, I think putting lines here in the names should make it more clear what these things are. Yeah, I think this makes some sense. We have start X and start Y. This is not entirely needed because we know that the start is at 0 and the end is at 100, but whatever. Yeah, we are subtracting 1 because of the walls. That is fine. Then we are getting the map. This is fine, I guess. Trim matches. Yeah, all right. Characters. Yeah, this is quite fine. And then this is the start position, the end position. Oh, here I guess we can say, instead of lines length -2, we can just say, hey, map length. And you don't like this because what? borrowed after move. Oh, because it's being moved here? That is interesting. Let's actually maybe extract these guys. So this is the start. This is the end. This is the end. Okay. Map, start, end. Beautiful. And that's it, I think. It was relatively short. It's just 100 lines for the implementation and a few lines more for the tests. Let's check that this thing still runs. No. Oh, type annotation is needed because probably we want to use it here. Well, yeah, okay. This should be a map, you know? Yeah, thank you. Does it run? Do I still have coffee? No. But it does run. Great. And does it test? It does test. All right. So I think that's it. I'm pretty happy with this solution, actually. We managed to do part 1 and part 2 at the same time, although it took 2 sittings, but it wasn't too hard. And that was day 24, the second to last day. So we are just one day more to go. Let's commit this as day 24 solution, if I can type. And I think that's gonna be it. I'm quite glad that this wasn't such a complicated day 24. It's not like if you go to Advent of Code 2021, yeah, this guy, I never finished it. In fact, I have 47 stars out of. Wait, am I still missing something else from this day? Yeah, I'm missing 2 stars and 1 star from the last day, because the last day gives you an extra star if you manage to get all the previous stars. And I didn't get any animation or like victory here, so I want to get back to this at some point. Maybe after Advent of Code 2022 is finished. But yeah, in the meantime, let's focus on day 25. Maybe tomorrow I will do that. And for now, I want to get some sleep. But if you have anything, thank you for watching and see you next time. Bye bye.